This video is designed to go with section 15.1 from the textbook Mathematics for Elementary Teachers by Musser. So we're going to use GeoGebra to illustrate how to show where the distance formula comes from. So the first thing that we're going to do are plot 3 points on a coordinate plane. And then we're going to connect those dots using line segments. All right, so we can easily tell what the distances are between these two sides because we are on a coordinate plane, and so the distance of units is going to be 1 unit. So because our scaling is 1. So we have 1, 2, 3 as a length of this side, and we have 1, 2, 3, 4 as a length of this side. And we can also have GeoGebra tell us that as well. So we have a length of 3 and a length of 4. So from here, we know that we can use the Pythagorean theorem to prove the length of the third side. So, according to the Pythagorean theorem, a squared plus b squared is supposed to be the hypotenuse squared. So, we have 3 squared plus 4 squared equals to the hypotenuse squared. So, let's evaluate this. 9 plus 16 will equal c squared, which means 25 equals c squared. And if I take the square root of both sides, I'm going to get that the length of C should be 5. And again, we can have GeoGebra show that for us. If I simply have it show me what the third side measures. And we can see that we do in fact get a length of 5. So now what we're going to do is we're going to use GeoGebra to do this using coordinate geometry. I'm going to show the ordered pairs that each of the following of the points are on. And we're going to see if we can figure out how to figure out the lengths based on the coordinates. So we can see that we have a length of 3 here. We did not move in the x direction, which means that our x values are exactly the same. They're both 5. Our y values are what changed. So if I want to figure out the distance here, I could simply do 5 minus 2, and I'm going to get 3. And this is just like walking a number line, because that's all an axis really is a number line. I can do the same thing by looking for the distances in the x's for the side of 4. Because my y value didn't change, notice that the y value is still 2, but I went from 5 to 9, and again, if I just count on the number line, I can see that I'm going to have a distance of 4 to get from 5 and 9. So what did we really do here? We looked at the distances between the ordered pairs. So how are we going to find the distance between this ordered pair and this ordered pair? And that's where we're going to use the Pythagorean theorem one more time and illustrate where the distance formula comes from. So let's take a look at our Pythagorean theorem one more time. According to the Pythagorean theorem, a squared plus b squared is supposed to equal c squared. Well, I know that I can find the distance of one side, because remember, a and b are the two sides and c is the hypotenuse. I know I can find the distance of one side by doing the change in my x's. So what we did here was I'll just write the ordered pairs here for reference. So we'll call, we have 5, 5, we have 5, 2, and then we have 9, 2. Okay, so I'll just make a small triangle here so that we can remember. So we can find the distance of this side to be 5 minus 2 squared. Okay, and that was taking these. And then we can find this side by doing 5 minus 9 squared. And that's going to have to be c squared. Now I want you to take a look at the two ordered pairs that end the line segment I'm looking for. Let's call this one x2, y2, and let's call this one x1, y1. What I really did here was I looked at the change in y, that's 5 minus 2, and then I looked at the change in x, that was the 5 minus 9. And the good news is that even though I had to subtract these the opposite way because I had to go in the same direction, it doesn't matter because I'm going to be squaring it. So my answer is going to come out positive no matter what. So this is going to wind up giving me 3 squared plus negative 4 squared equals c squared, which is still 9 plus 16, which is 25. And then if I take the square root of both sides, I wind up getting 5. And so I can use coordinate geometry to show that the distance formula is the square root of x2 minus x1 squared plus y2 minus y1 squared. Because again, what did I do? I had to look at the change in x's to find one of the sides. I had to look at the change in y to find the other side. And then, because of the Pythagorean theorem, that was side squared plus side squared equals d squared. So in order to solve for d, I have to take the square root of both sides. And so that is how you can come up with the distance formula so that you don't have to memorize it.